Welcome to another episode of Ask Better Questions. In today's episode, we'll delve deeper into machine learning. But before we get into the episode, I'd like to take a moment to thank our sponsor, Color4 Solutions. And as always, I'm a director at Color4 Solutions, and we provide independent advice on AI implementations for business looking to automate any business function. So if you're in the market to automate or implement AI in any of your business processes, be sure to reach out. Links are in the description. So I'll just mention here that before we get into the episode, towards the end of today's episode, I'll be reading an excerpt from my book titled Leadership in the Artificial Intelligence Age. So today's world is rapidly changing, and a huge part of that is driven at least in part by AI. So my book attempts to condense what these changes are, what we're already seeing, what we can expect to see more of, and what leaders can and should be doing about it. What skills are needed in this new age, what sort of things should be, what actions should be taken. So having got the introduction out of the way, brace yourselves for another technical episode. So I have a great deal of expertise with machine learning, having developed and deployed dozens of machine learning systems for banks, insurance companies, and other organizations. Predominantly my experience stems from OCR software and a large mass production of reading automated forms, things like landing cards, things like applications for loans, bank forms and insurance forms and the like, as well as working for government departments for digesting and digitizing information that's submitted by handwritten form. So let's kick into it. I guess we'll start by saying, what is machine learning? So machine learning is a subset of artificial intelligence that involves development of algorithms and statistical models that enable computers to improve their performance on a task over time without being explicitly programmed. So what are the main types of that? So the main types of machine learning are supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the algorithm is trained on labeled data. So in unsupervised learning, that involves finding patterns in unlabeled data. Reinforcement learning involves training an algorithm to make sequences of decisions by receiving feedback in the form of rewards and punishments. Effectively, what I've done a lot in the past is intelligent learning, but predominantly what would be supervised learning. So in terms of giving the computer and the machine a whole bunch of data that we've already labeled as this is a 3, this is an 8, this is a 6, and then getting the machine to learn what 6s are, what's different for a 6 than a 3, and then being able to identify those at rapid rates. So a lot of it was programming what you can expect to see in these fields and what you would not expect to see. So you understand the difference between a G and a 6 or a 9, and you can tell what the difference is. But a lot of the times it looks very similar. But if you can tell the form and you can tell the machine what it will expect to see, then it can narrow it down and improve its performance and accuracy quite significantly. So what's the difference between overlifting and underlifting in machine learning? All right, so overlifting occurs when a model learns the training data too well, so including its noise and outliers, but fails to generalize to new and unseen data. Underlifting happens when a model is too simple to capture the underlying patterns in the training data and performs poorly on both training and new data. Typically, you don't see a lot of underlifting, because if you're seeing underlifting in training data, and it doesn't secure accuracy, then you go back to the drawing board, you get more data, and you train the model again, or you tinker with the model. So what is bias variance trade-off? So bias variance trade-off is a key concept in machine learning. Bias refers to the error introduced by approximating a real-world problem with too simplistic a model, while variance refers to the model's sensitivity to variation in the training data. So the trade-off involves finding the right level of model complexity that minimizes both bias and variance to achieve optimal predictive performance. Ideally, what you're looking for is an error rate of less than 0.5%. And when you're talking large volumes of data, you want to be aiming for 0.1 or less of a percent, because you might be processing hundreds of thousands of forms. And you might be processing a lot of real world data, and you want to see variance or an underperformance or an inaccuracy rate very, very low. So what's the role of feature engineering and machine learning? So feature engineering involves selecting, transforming, or creating input features to improve performance of a machine learning model. Well-engineered features can enhance a model's ability to capture relevant patterns and relationships in the data, leading to improved predictive accuracy. So feature engineering is tinkering with your algorithms to make, and sometimes adding new, I suppose not new data sets or new parameters, but tinkering with what you've existingly got to make your model more accurate. What is a neural network? Well, we've covered this off in the last episode, but a neural network is a computational model inspired by the structure and function of the human brain. If you want to know more about it, I cover it off a little bit more in last week's episode, but I will be covering it off in more detail next week. It consists of layers of interconnected nodes, which are neurons, that process and transform input data. So neural networks are fundamental components of deep learning, a subset of machine learning. So what's the purpose of regularization in machine learning? So regularization is a technique that is used to prevent overlifting in machine learning. It involves adding a penalty term to the model's objective function, so discouraging overly complex models by penalizing large coefficients. This helps improve the model's generalization to new and unseen data. Ideally, you want to avoid overcomplication because it overcomplicates, but it also involves increased computational power, increased lag, and the longer a machine has to spend looking at something, the slower the overall processing will happen. So you want to try and have as simplistic a model as possible, which is why a lot of the design of these systems has to be very well done. And you find organizations that specialize in various types of machine learning. So what is cross-validation and why is it important? So cross-validation is a technique that's used to assess the performance and generalization of a machine learning model by partitioning the data sets into multiple subsets. So the model is trained on some subsets and tested on others. So iteratively, this testing occurs. All right. So cross-validation provides a more robust evaluation of a model's performance compared to a single train test split. So if you like train test, especially when your data set is limited, you'll train on one set of data and test on a separate set of data, as opposed to, or train on one specific input and then test your output versus as a second input or second output. So what's the difference between classification and regression in machine learning? So classification is a type of machine learning task where a goal is to predict the category or class of an observation. Regression, on the other hand, involves predicting a continuous quantity or numerical value. In classification, the output is discrete, i.e. spam or not spam, while in regression, the output is continuous, i.e. like predicting house prices, so which can be an ongoing prediction. So what is, we'll just cover off one last one. What is transfer learning in the context of machine learning? So transfer learning is a machine learning technique where a model trained on one task is adapted for a related but different task. Instead of training a model from scratch, transfer learning leverages knowledge gained from solving one problem to improve performance on a different but related problem. This can significantly reduce the amount of labeled data required for training. For instance, when it comes to handwriting and stuff like that, we had a large database of handwriting, which we constantly updated and expanded for these particular type of tasks. But then we could then adapt that to other subsets of data. So, for instance, the machine could recognize numbers, and it would use number recognition and letter recognition for a number of different tasks. But again, you would be measuring the output and you'd be measuring the accuracy. So I'm going to take this moment now to read an excerpt from my upcoming book, which will be released in the next week or so, probably within the next few days. It does cover off things like what the background is for AI and why it's becoming so prevalent. And predominantly, as a quick hint, it's because there's so much data around now so that we can train AI models on almost endless amounts of data. But I thought I might read an excerpt from Chapter 3, The Changing Landscape and the Shifting Paradigms in Organizational Management. So, the advent of artificial intelligence has brought about a significant shift in the landscape of organizational management. As businesses strive to stay competitive in a rapidly evolving world, traditional management approaches are being challenged and new paradigms are emerging. In this chapter, we delve deeper into the changing landscapes of organizational management and explore the multifaceted implications of AI on leadership and organizational dynamics. We will discuss how AI is transforming various aspects of management, including decision-making processes, customer engagement, workforce dynamics, and organizational culture. One of the primary shifts brought about by AI is the move from top-down hierarchical models to more decentralized agile structures. With AI technology enabling faster and more efficient decision-making, organizations are embracing a more collaborative and network style of management. Agile methodologies such as Scrum and Kanban are being adopted to empower cross-functional teams and foster a culture of autonomy, innovation, and accountability. This paradigm shift emphasizes the need for leaders to become facilitators and enablers for their teams to make swift and data-driven decisions, ultimately driving organizational success. Furthermore, the rise of AI has ushered in an era of data-driven decision-making, with AI algorithms capable of processing vast amounts of data and providing valuable insights. Leaders are now expected to base their decisions on objective analysis rather than intuition alone. This requires a shift in mindset, as leaders must become proficient in data interpretation, recognizing patterns, and identifying correlations to make informed decisions that align with the organization's strategic goals. Effective leaders are those who can leverage AI to gather actionable insights from complex data sets, enabling them to drive innovation and enhanced operational efficiency. So the chapter goes on, covers a great deal of the other things, the culture play that is happening within organizations, and what this paradigm shift from top-down autocratic to agile methodology will mean. This isn't something that is new and entirely driven by AI, but it's certainly been made faster by AI. You're going to find that the larger organizations will struggle in this environment without making these changes quickly, because smaller, more agile competitors will eat their lunch and they won't even realize it's happened until it's too late. So unless you're in an industry that is particularly bound and protected from competition by regulation perhaps, or something similar, you may find that, and even those that are, will probably find that smaller, more agile competitors will take away a vast majority of their client base, and they will end up serving people that are unprofitable or lower margin clients. But anyway, the book goes into a lot more depth than I will do so here. But if that's sort of what you whistle and you're interested, the book is available on Amazon, and more information will be available with the book's release in the next day or two. So having said that, in next week's episode, I'll be tackling neural networks in depth. If you're interested in what AI can do for your business, please reach out via the links in the description. If you like the podcast, leave a rating and review and subscribe so you don't miss an episode. I'm Peter Adams, and I'll be here next week to ask better questions.